Auzubillahiminashaitanirrajim. Bismillahirrahmanirrahim. So this is going to be the part 2 or the second part of the introduction to periodic table that we started in our previous video. Here you can see there's a periodic table of elements shown all the boxes with only one box which is highlighted with orange. So this is the position of actually the hydrogen in periodic table. Hydrogen is actually one of the elements of the periodic table which do not fit according to its properties, all the major properties in group 1, but still it is a part of, sometimes it is added as a part of group 1 because of one electron in its outermost shell. As we have discussed earlier in our previous video, we have discussed that the total number of electrons in the last shell of any element is actually its group number. So hydrogen, as we all know, is having only one single electron. So whether it's the first shell or the last shell, there is only one electron in hydrogen, so definitely it is going to be in group 1. But according to its other physical and chemical properties which are not alike or which are not similar with the rest of the elements which are present down the group, like for example, hydrogen is a completely unknown metal. Why? Because it exists in a gaseous state. While other elements of the same group, that is sodium, lithium, potassium, rubidium, cesium, francium, all these elements which are present down the group below the hydrogen are actually perfectly metals. Hydrogen exists in gaseous state, other elements of the same group exist in a solid state. So definitely if this is a gaseous state and others are in the form of solid state, so there will be a definitely freezing, melting point, boiling point, which will all be different, or along with, if you're talking about the density of this element, definitely it will be different. Plus hydrogen always exists in a diatomic form. That means two number of atoms of the same element of hydrogen as actually bound together to make a hydrogen gas. So hydrogen is never found alone. While in case of anything which are present down the group, there are mostly monatomic conditions which are there present. So hydrogen, because of its only one single property, that it has only one electron in its outermost shell, it is present in group 1. Otherwise, some periodic table mention it as a separate class of its own, while others just do present it in the form of group 1a, but the properties are not of the same group. Then you can see below the position of hydrogen, there are the elements which are shown actually in highlighted with yellow, and then we have structures for group 2. Then we have like this is the highlighted portion that is actually showing the transition elements. So this portion which is actually highlighted in blue is called as the type 2 elements. So the first one, which were from 1, 2, 3, 4, 5, 6, 7, and 8. These extreme right hand sides and extreme left hand sides these are basically the type A, or the type of elements which are categorized as A. So these were actually the normal elements or the representative elements with very basic or specific properties. But if I'm talking about the elements which are present in the middle, which is actually highlighted blue right now, these are called as B-type elements, and these are also called as transition elements. These do not have a fixed amount of number of electrons which they are going to have participated in some sort of chemical reactions. Rather, some of them sometimes show +2 ionization, sometimes they show +3 ionization, or the amount of electrons they share is different. So these are basically the transition elements in which the electrons keep jumping from one shell to another shell. Then in this, this is going to be the third 3A, which is one of the normal elements of the representative elements of type A. Then it's going to be fourth, fifth group, and this is going to be the 6th, 7th, and the last one is 8th. So these were actually the structures which are called as normal elements. Now there is a portion which is actually separated from the main periodic table. These are called as Inner transition elements are also called as rare earth elements. These have been separated from the major group because because of their chemical properties, they are actually, most of them are radioactive in nature. And these are the elements which are drawn or which are formed by disintegration of the other transition elements after the destruction or disintegration of their nuclei and the atoms. These are called as rare earth elements because these are found from earth crust, and most of them are rarely found. They are so low in number that the huge amounts or deposits of these have not been extracted from the earth. So according to their radioactivity, according to their discovery, according to their positions, they have been named separately as lanthanide series and actinide series. Now coming one by one to the properties of the elements which are present in any group. As hydrogen, as we have discussed earlier, that it has class of its own. So hydrogen square sits atop family A1, but it is not a member of that family. Hydrogen is in a class of its own. It's a gas at room temperature. Hydrogen is a diatomic reactive gas. It has one proton, one electron in its one and only energy level. And that is the major reason that it is placed in the group 1. Hydrogen only needs one electron to fill up its valence shell. Just to repeat from the previous things that we studied during the class, we have got two major rules that was actually the part of the things or the part of arrangement of electrons. The first one was the duplet rule, and the second one was called as octet rule, or the rule of duplet and the rule of octet. The rule of duplet says if it applies only to hydrogen and helium. So the first shell of any element, first shell means the shell that is very next to the nucleus, the innermost shell, can accommodate only 2 electrons, while the rest of the shells which are coming along after the first shell can accommodate 8 electrons. So the first shell, for example, hydrogen, it has only one single shell, and that is going to be its first and last shell. So it has vacancy for only 2 electrons, while hydrogen has only 1 electron. So it requires, according to duplet rule, it requires only 1 electron to complete its shell. While in case of helium, definitely it has 2 electrons and it has only 1 shell. So one and the only shell is already complete according to the rule of duplet. Then there are alkali metals, which are actually the elements which are below the hydrogen in group 1. So group 1 elements apart from hydrogen are called as alkali metals. These are also called as S-block elements because their last subshell that is either filled or is in the process of filling is the S subshell. These alkali metals are found in the first column of the periodic table. Atoms of the alkali metals have a single electron in their outermost level. In other words, one valence electron. They are shiny, have the consistency of clay, and are easily cut with the knife. For example, just we can have example of butter, solid butter in our minds, that they are just like that and they can be easily cut with the help of a knife. Example, they are most reactive metals. They react violently with water. So they cause severely exothermic reactions, and immense amount of heat along with fire is produced. So alkali metals are never found in free elements in nature. They are always bonded with another elements. So they are, according to their nature of violence with water, or they react violently with water, they need to kept in a closed airtight jar so that even not a little moisture can interact with this piece if they are stored. Then the reactivity, what does it mean to be reactive? For example, if I have used the word they are violently reactive or they violently react with water. So what is meant by reactivity actually? We will be describing elements according to their reactivity. Elements which are reactive bond easily with elements to make compounds. So being reactive means the elements which are reactive means their valence electron or the last electron is easily available for the other electrons to be bonded. So whenever they find compatible element in front of them with whom they can share electrons, or with whom they can gain electrons, or to whom they can give their electrons, they bind easily. So whenever the element is when two atoms are compared from the same class, and one is readily available to make a bond and other one takes time or energies to make a bond, the first one is the former one is called as more reactive than the later one. Some elements are only found in nature bonded with other elements. What makes an element reactive? Definitely there is a reason behind reactivity. So whenever there is, for example, an element whose outermost shell is complete, or it does not have any positive or negative charge, then there is no need of any to an atom that it is going to bond. There are two major things on the basis of which any atom is actually interested to make a bond with any other atom. Number one being they have outermost shell incomplete, so they need to complete their outermost shell, whether following the rule of duplet in case of hydrogen or rule of octet in case of any other element. So if they have to complete their last outermost shell of electrons, then definitely they have to bond. Or in other words, if they have electrons which is actually complete in their structures, but they do have a positive or negative charge, so to stabilize their charge, to stabilize their to get them into a neutral state, they definitely need to make a bond with any other element which can actually neutralize them. So to either they have to complete the shell or they have to make them neutralized, they really make a bond. So it says that an incomplete valence electron level, or all atoms except hydrogen want to have 8 electrons in their very outermost energy level, and this is called as rule of octet that I have already explained. Atoms bond until this level is complete. Atoms with few valence electrons lose them during bonding. Atoms with 6, 7 or 8 valence electrons gain electrons during bonding. So this is the need of reactivity, and this is how elements are said to be more or less reactive. Now you can see with reference to the alkali metals and the halogens because of their reactivity. As you can see, sodium has only one electron in the outermost shell, or simply called as one valence electrons. I'm repeating, the valence electron is the electron which is actually present in the outermost shell, and the outermost shell of any atom is called as valence shell. So sodium has only one valence electron in its valence shell, while chlorine has 7 electrons in its valence shell. So as we know, sodium has to complete its 8 electrons, but it's really hard to gain 7 more electrons. Rather, sodium prefers to lose its 1 electron of the outermost shell, and when it loses, the outermost shell becomes the second shell, which is already complete with 8 electrons. So sodium is good to go with losing the 1 electron. While in case of chlorine, it already has 7 electrons and it needs just 1 to complete its third shell. So when sodium is ready to give, chlorine is ready to take. So this give and take relationship gets converted into ionic bond, in which sodium completely loses its 1 electron to chlorine, and chlorine gains this 1 electron to complete its shell. So in this way, sodium and chlorine both becomes bonded, and as a result, sodium chloride salt is formed, and sodium becomes positive because of loss of electron, and the chlorine becomes negative due to gain of extra electron, and as a result, one is positive, other one is negative, and overall this salt that has just been formed in the form of sodium chloride is a neutral salt, so it does not have any specific charge on them. The next group that we are going to study is alkaline earth metals. These are never found uncombined in nature. They have 2 valence electrons. Alkaline earth metals include nutrients like magnesium and calcium, and most of these you have heard about the any sort of food supplements you can see. These are also S block elements, so definitely the last subshell that is filled or needs to be filled is S shell. Then there are transition elements, as we have already mentioned, are those elements in the B families. These are the metals. You are probably most familiar: copper, tin, zinc, iron, nickel, gold, and silver. Gold and silver being less reactive and hard metals, while copper, tin, zinc, iron, nickel are more reactive and relatively less hard. And the gold and silver, because of their less reactivity and hard nature, is making them one of the precious metals. Then they are good conductors of heat and electricity, and includes metals used in jewelry and construction, metals used as metals.